In problem 3, we're given a displacement vector, and let's call that displacement vector d, and the displacement vector is the vector that an object makes from a starting point, maybe the origin, to an ending point, given by, in this case, a magnitude of 215 kilometers and an angle that is 22 degrees east of north. So the angle is with reference to the north axis, so that's why you see the angle is relative to the vertical axis, not the horizontal one. So let's go ahead and first find what this angle theta is. Theta is 90 degrees minus the 22 degrees, or 68 degrees. And now we can say that the x component of vector d, if we look at a triangle made between the vector, we see that this is the x component of vector d and this is the y component of vector d. And since the x component of vector d is along the adjacent side of the angle, then we can say that the x component of vector d is the magnitude of vector d times the cosine of the angle theta. So we can say that dx is 215 kilometers times cosine of 68 degrees. And keeping in mind significant figures, we will get an answer of 81 kilometers. And then the y component of d vector is dy, and that would be, again, d times sine of theta, because the y component is the opposite side of the angle. And again, applying the values that we are given, we get 215 kilometers times sine of 68 degrees, or this is about 199 kilometers, but to keep with the scientific notation, since we need only two significant figures, this would be 2.0 times 10 to the second kilometers. On a quiz or an exam, if you leave it this way, I might not take points off, but just know that if you see this in a book or in my solutions, that's where this came from.